Well, greetings everyone. I wanted to show off a little piece of equipment that I built many years ago that's been quite handy from time to time on the workbench here. And I don't know if you would call this a piece of test equipment, or it's more of a piece of lab equipment really. It can be used for testing, of course, but it's a constant current power supply. And what it does is it puts out according to the way you have it adjusted here, it will regulate the current going to anything you want to hook to the terminals here, whether it's a diode or an LED for instance, or even charging batteries. It will stay set where you place it. And let me just plug it in and turn the power on here. And this is the power light, power switch, and this is the current control. Now, you really don't know how much current is flowing through this without having a load on it. So we're going to go ahead and connect the way I'll demonstrate this here is I have a couple of, let me back off just a little bit on the camera. And what you can do is when you hook this up and you short these leads together, you'll see a reading on the meter, and you can adjust that reading for the amount of current control that you want in this circuit. It's a little different than what it is from a variable voltage type power supply, because this just regulates the current. And right now we've got it set on the low 50 milliamp scale, and I'm going to set it to 10 milliamps, which is almost as low as it will go, with the leads shorted. So anything you put across the leads now, whether it's a light emitting diode like this, see if I can get my hands around this, and we'll put it here, and as you can see on the meter, it's still 10 milliamps, and it doesn't really care what the what kind of load you're going to put on it, because it's going to regulate it to that current level. Now I can turn this up to say 15. I don't want to go any higher because I don't want to burn out the LED, because I think it's rated for 10 to 15 forward bias on the milliamp scale. So you can use it to check that, and it doesn't matter if you accidentally have the leads reversed on this and you reverse bias this. Nothing's going to happen on the meter, as you can see. Or even if you short it out accidentally, it's just going to limit it to 15 milliamps or wherever you set it. Now you can also use this to charge batteries, as long as they are rechargeable. I wouldn't put one in there that isn't, but this is the negative lead here, as you can see, and the positive we'll put right here. And as you can see now, it's still at 10 milliamps. Now this battery can be charged up to a full ampere if you want to, and we can change this to the 500 milliamp scale, as you can see there, and turn this up to, we can make it go up to 400 milliamps right here. And it will charge it all day long at that. Now you're probably wondering what the terminal voltage is at any given time. And let me just bring my voltmeter over here, and we'll set it alongside this and get the camera situated here so we can see. And I will hook it up to, see if we can get the leads in here just right. And as you can see now, The battery is a nickel metal hydride battery, and they're usually around 1.3, 1.5 volts, but let me begin turning up the current again. And we'll just stop here. Right around 300 milliamperes. And its terminal voltage is 2.2 volts. Now if we disconnect this, you'll see that it jumps clear up to 38 volts, which is the input supply to the regulator chip in this, and it uses an LM317 regulator chip, which is normally a voltage regulator, but I have it configured and wired as a constant current regulator, and I will show you how to do that. And actually we can take the cover off this, and I can show you how I put it together, and maybe we'll find out what year I made this in. So why don't we do that? We'll just turn this off and unplug it and get some of this out of the way here. Here we are. And let's just take the screws out of it. And I don't even know where I got this box, but it's an old one. And I think we have two more to go here. Okay. Just set those aside in the thing, and let's see if we can get the cover off this thing. And there we are. And that's the insides there. And oh look, I drew a schematic for it there, and you can see it. And it has a built date of May the 24th, 1985. I told you it was old. Almost half as old as I am now. So, but this is what it looks like inside. And let me get the, I dug out the schematic for this, and I'll show you how this works and how it's wired, and how you can make one yourself. And it's very, very simple. I know this looks a little complicated, but it really isn't. Get over here and get a bit of a pointer so I can point a few things out to you. Okay, so really right in the center here you see the LM317 adjustable regulator. And it is configured to do current regulation instead of voltage regulation. So really the entire circuit for that regulator is just between my hands here, and it's only consists of a variable resistor, a pot, and a capacitor, and a diode. And you don't even really need that, but I just put it in there, and I'll explain that here in a second. But starting from the very beginning, where we have our plug-in to the wall receptacle, we have 120 volts coming through a switch and a very small fuse, 0.01 amps. It doesn't take much of a fuse for this. Into a transformer. It's a 120 volt primary and a 24 volt AC secondary. We go through a bridge rectifier, and after we do a full wave rectification of the signal, we filter it a little bit with a C1 here, which is a 1000 microfarad 50 volt capacitor, because this will give us unregulated, unloaded output of around 34 to 38 volts DC in this configuration. This is the power LED and a current limiting resistor for the LED. It's just the indicator. And from there we push it into the input pin, which is pin 3 of an LM317 adjustable regulator. And number 1 is the adjustment pin, number 2 is the output pin, and from there the voltage or the current comes through this D2, which is basically a safety diode to in case you hooks up something backwards. Maybe you want to charge a battery or something and you accidentally hook it up backwards. It will not, that'll block it from feeding back into the regulator. And we have a current meter. I chose a 500 milliamp full scale meter, and the one I am using here, of course, is has several scales on it, and as you can see it on the left, I have a 3-position rotary switch to where you can change the range of that, and you can do whatever you want to do with. Now, I realize that you can probably buy this circuit pre-made from Marlin P. Jones or something like that for probably $5, maybe 10. But you know, where's the fun in that? We really want to have a little enjoyment and learn something out of this. So, and this is a very simple circuit that we can learn from, and you can tailor make it to however you want to use it. On my metering circuit here, I have these 3 positions for 50, 150, and 500 milliamp scale, 1, 2, and 3. And I'm using a 2-pole 3-position rotary switch. Now, you don't need to use that. You don't need to do that. You can configure it any way you want. And the resistors I've ended up choosing to shunt my meter are 0.25 ohm, 0.78 ohm. You're probably going to end up making your own, and it's very easy. I'll show you how to do that here in a second. But it's probably going to be hard to find a 0.25 and a 0.78 ohm, but I'll show you how to do that. And of course, then from there it goes to the output terminals, and that's the way the circuit works. Now we can let's just go in here and take a quick look at how I built this thing, if I can remember. And of course, the power plug comes in here, goes to the switch. The other lead, which is could be a line or neutral, it doesn't matter, it's non-polarized. Of course, goes through the fuse, then to the transformer, and from the transformer to the bridge rectifier, as you can see right down here. It's kind of in the dark there. Let me see if I can get a little more light on it. And through a dropping resistor to here to the LED indicator light. And the voltage regulator chip itself is right here. And I'll see if I can get that on the camera to where you can see it. It's right here. It's just a little 3-terminal tab type voltage regulator, hidden behind the wires here, of course. And it is screwed to the case here, as it's case makes a fine heat sink for it. And you may have to insulate it from the case if you decide to use a case as a ground. You'll definitely have to insulate that. This is the potentiometer I chose. It's a 200 ohm pot, and you could probably get away with a 500, and just experiment around with it a little bit. Now the resistors that I chose for the shunt for the meter are right here, and as you can see, they are 1 ohm resistors, and I had to parallel them with a 1.02 ohm resistor to get them down to the 0.78 ohms that are required to calibrate the meter. And the other resistor, the 0.2 ohm, if you look down here, you see this odd looking contraption here that has the blue wire around it. It's another resistor with a lot of turns of wire on it, and I just took the wire and I kept clipping off a little more and a little more and a little more until the resistance got down to what I needed for that meter. And so you can make your own that way. It is not critical except for the calibration of it, but I just wrapped some single-stranded wire around a resistor and made my own. And you can do the same. Any kind of thin wire works the best. This is just from a wire wrap tool and project that I did earlier. And of course here are the output terminals right there. But that's it's become quite invaluable at times to have a constant current supply. We don't have to worry about the voltage or shorting it out, because it just, as I said earlier, will just drop the current to where you set it on the meter there. And if I plug it in again, turn it on, again, all you really need to do is short the leads together and set the meter where you want it to go. And then remove the short circuit and put on anything you want to test, charge up, or otherwise play around with. So another thing I've built was this. If you have hearing aids and have rechargeable hearing aid batteries like this, you're probably wondering where you can get a battery holder for it. And I just made one out of a clothespin and 2 brass tacks, and then you can hook your leads solder them to the brass, and then when you want to charge your battery, anyway, you can put that on there like that and then charge it up. Now I want to caution you, do not charge any button battery that isn't specifically rechargeable. It will explode on you every time. So just a word of caution for you. But if you have a battery, maybe you have a cell that doesn't, you don't have a charger for, and you don't want to incur the expense of ordering and buying one, you can just plug it right into this, set your current, and we'll let her go for several hours until the voltage reaches the rated voltage of the battery, and you've got yourself an easy charger there. So anyway, I just wanted to demonstrate that to you, and thank you for watching, and hope you got a little bit of something out of this. You can add this to your bench as another piece of equipment. Help populate your brand new workbench. And if you would like a PDF of this schematic, just shoot me an email to the address on the screen at yahoo.com. This way I won't get deluged by a bunch of junk mail. So anyway, thanks again for watching. Catch you next time.